everybody, it's shazizz here. This is the little nifty gizmo that you're looking at. I just wanted to share it with you because it's an interesting concept. If you look in those spheres that are on each end of this thing, those were some 3D printed spheres that Mark Brash made over there at Zero Fossil Fuel that he'd sent to me a long time ago. I've been trying to do some experiments with. But inside those plastic spheres are neodymium magnets. And if you look down real close in this video, at the bottom of in the middle, you'll see a little neodymium magnet in a little plastic shot glass that sits pretty far away, and you can see the little magnet rocking back and forth, I hope, with this video. Anyway, I'm going to go over there real quick, and I'm going to stop this thing just for a second so I can point out a couple things, and I'll try to talk loudly enough where you can hear me from over there. Okay, if you look closely, you can see that little neodymium magnet right there wobbling back and forth as the magnets are spinning around. And you could actually put on an outer ring out here from as far as these magnetic fields for these neodymium magnets would attach each other as far as coupling with the field. And so it doesn't matter how many of these you got, just as long as they're not close enough for that field strength to actually suck those magnets together. So I'm going to stop this just for a second. And I don't know if you can see, there's a solar panel here, there's a solar panel there, and a rechargeable 1.5 volt battery. These little electric motors here are like little micro motors for RCs, and they're actually they'll run up to 3 volts, and I just buzzed my finger with that. Anyway, they'll run up to 3 volts, but they'll also run down as low as I think a volt. And I've got 2 of these running parallel with each other, and there's 2, like I said, 2 solar panels. But also, I don't think you can see it, but on this side you'll see there's a, doggone it, there's a set of capacitors. It's about 9 separate capacitors. I'm not even sure what the voltage are. I think they were like 12 volts altogether. Notice that the magnet stopped wobbling. And so these 2 little solar panels are picking up light off of this light up here, which isn't the whole thing that's running. It's mostly the energy that's in the battery. These solar panels are probably just at this point buying time. But anyway, I'm going to let this thing go again. And this fan is blowing that way while this fan is blowing this way. And this is built off of a CD, old CD case that you actually buy stacks of CDs in. And it's sitting on a wooden dowel rod. And there's a little ball inside there that's actually acting as a bearing in there. So I'm going to let this go. You see that neodymium magnet's starting to wobble again. Now the concept for this idea was that if you had onboard capacitor banks and all that kind of stuff, that you could get this thing using the little airplane motors to start spinning around as long as the sun was out. And when the clouds came in the way and blocked out the sun, the capacitor banks would keep it spinning for a little bit of time. But the key is that that magnetic field right there would be all the way surrounded, and you could put coils all the way around this thing that, as those magnets were coming around, would be energizing a little bit of voltage into those coils. So basically you'd be using solar power to charge up your capacitor banks using supercapacitors and some batteries, and that would be independent of any charging system that you would build down here. If that magnetic field can actually interact with that magnet that distance right there, you would definitely be able to induce a current into a coil of wire. And so with that said, getting it just right to where the magnets aren't attracting each other, or even designing the fan blades themselves to actually push out more wind. This is pretty impressive. If you actually did the mathematics of the size of the motor compared to the weight of 4 3/4-inch neodymium magnets, plus the weight of the battery, plus the weight of the motors themselves, plus the weight of the 2 CDs that's on there, and the actual case that it's all riding on, I think you'd find something pretty interesting in it if you actually did the math on it. But if it was designed right and large enough, you could literally build a generator that would spin around when the sun's out, cloud comes in the way of the sun, it still has enough stored energy plus a little bit of sunlight still able to get even through the clouds, and it would keep going. And at the same time, on this same platform, you could build turbines that would ride around with this, and as the wind is circulating those turbines, also putting more energy back into this system. So to some extent, just the motion of this turning in itself could put a little bit of juice back in there. Of course, I know I'm going to get a bunch of haters saying, well, you could never get enough juice to, you're not going to get out more than you put in. Well, understand the concept that's going on here. We're not trying to get out more than we're actually putting in. The only thing we want to do is be able to get out just what's necessary to run those fans to keep this thing rotating around in a vortex circle like that. And as it's going around, your actual turbines could be out here where your tip speed is just a little bit faster than the center portion of there. And so the turbines designed properly, as they were spinning around, could literally turn those turbines faster than it would be normally if they were sitting closer to the center. And so with a little bit of engineering, you could actually take this somewhere. Right now it's just a toy for testing purposes, but nonetheless, that little 1.5 volt battery that I've had on there, actually been tinkering around with this for probably at least an hour before I ever even started up this video. And so imagine a huge merry-go-round with maybe even multiple motors on there to actually get it to spinning faster, concreted into the ground, where you could actually use some, I don't know what all that is, where you could actually use some wind power. Hold on, I know exactly what it is. Alright, hey, how's it going there? I'm right in the middle of recording a video. Give me a minute. Alright, so, sorry about that. That's Ken over there at Revolution Green. You need to go over and check his stuff out too, because he's got some stuff that he could share with you, his research he's done. Get that just in a right, there you go. See, there's that magnet moving around in that side there. And of course, you're going to have to make sure that if you start using neospheres inside, like maybe a coil, that you can make sure that's mounted down where it ain't going to be sucked towards this. But either way, I wanted to share that with you folks, to let you take a good look at that real quick. That's 2 fans on a CD turning turning the whole deal with 4 neodymium magnets that are 3/4 inch spheres. There's 2 solar panels in there. I'm anxious to take this out in the sunlight because what I'm using right now is just a fluorescent lighting above, but I was able to at least get 0.90 volts out of it just the way it is inside with existing light. So that 0.90 volts, even though it doesn't have a lot of current to it, is enough to keep a little bit of energy back in that deal and extend the life of this battery at the very least. So there you go, folks. That's another one of old Shazizz's nifty gizmos. And I'm going to keep working on this because I think it's pretty neat. So anyway, peace and love, everybody. Stay tuned for updates on this. Notice what that magnet's starting to wobble again. The faster this thing gets to going. And you also saw that it did have enough wind power to get it started on its own once I let go of it. There it goes. If I get it too close, it'll suck over there and bust a little plastic glass. So anyway, peace and love, everybody. Hope you liked the video. If you did, share it. Thanks. Hello everybody, it's old Shazizz. I'm here again because I started noticing an anomaly while this thing was running. The longer it was running, you see that sphere right there is starting to spin around a whole lot more. Well, I actually had to put a piece of aluminum tape on there because it was literally from where it was dragging the little shot glass closer and closer. But I wanted to add this to this video because this is an interesting effect that if you can get it measured out just right, you can get those neospheres in the right coils to literally produce more electricity. So this is just a little addendum to what I was working on already. I'll play this for just a little bit longer here, and then I'll go ahead and wrap this video up. But check out what's going on with that magnet inside there. Now keep in mind, you could put magnets in a complete circle all the way around at the same radius and still get the same effect out of the same amount of energy input. And this thing's still going, and I'm on a call right now. Probably been there for at least 10 or 15 minutes, I'm sure. And plus the hour that I ran it before. I'm just going to let this battery run itself down, and then in the next update I'll let you know how long that battery actually lasted, just with the existing light up here at the top. Alright everybody, stay tuned. Peace and love. Take care. Okay everybody, one little short addendum. It's moving a little bit slower, but at the very least an hour and a half into running that battery. So at one point it did come to a stop, so that I took the little magnet, the neodymium magnet, away from it, which was slowing it down. And so now I'm going to let it run down like this. Peace and love everybody, stay tuned. Hello everybody, it's me again. Basically the battery that I put in here, the 1.5 volt battery, and the systems that I explained earlier, has kept this thing running for over 2.5 hours. Right now it's finally come to a complete stop, but if you listen closely you should be able to hear that those engines are still turning. I'll go over and actually put my finger on one of the blades so you can actually hear it. So, with that said, even though it's running down and doesn't have enough thrust to actually spin it around, the motors are still turning. So I think that's pretty good first result for this little experiment of this nifty gizmo. So with that said, last addendum in this video. Peace and love. Take care.